We all kind of take infinity for granted, right? This endless, boundless idea that's at the heart of so much math. But what if I told you it's, well, not real? A useful story, maybe, but just a story. And what if the AI we're all talking about today is actually built on that very idea, that infinity is a myth? Yeah, that's the rabbit hole we're about to go down. All right, so here's the plan for our little journey. First, we're going to poke some holes in the whole idea of infinity. Then, we'll meet these philosophical rebels called the ultra-finitists. We'll see how their wild idea is a cheat code to get around one of the most famous theorems in all of math. And this is where it gets really interesting. We're going to connect all this to AI and how it might just be the living proof of their theory. It's going to lead us to some seriously weird questions about what truth even is.
Okay, let's dive right in. Section 1, the myth of infinity. I mean, for centuries, this idea has been a bedrock of pure math. But what if it doesn't actually exist in the real world? Like, at all?
So, let's just get it out there. The big one. Is infinity real? I mean, really think about it. We throw the term around all the time, but have you ever actually seen one, touched one? Can you point to an infinity out there in the world? And this is where we hit a major fork in the road. See, in one direction, you've got the world of pure mass. It's beautiful, it's abstract, and it's filled with ideas that just go on and on forever. But in the other direction, well, you've got the actual physical universe. And science is pretty clear on this. Our universe is huge, yeah, but it's not infinite. It had a beginning, the Big Bang. It's going to have an end. Everything inside it, from stars to atoms, is countable, finite. And it's this huge clash, this tension between the endless ideas in our heads and the limited world under our feet that really gets this whole thing started. Okay, check this out. Take the number pi. We all learned in school it goes on forever, right? An infinite string of digits. But get this. If you wanted to calculate the circumference of the entire observable universe down to the accuracy of a single hydrogen atom, you'd only need about 40 digits of pi. 40. After that, for any real-world physical purpose, the rest of those infinite digits are just noise. Our reality, it seems, just doesn't have a need for infinity. So this massive gap between theory and reality, it didn't go unnoticed, and it led to a kind of rebellion. Which brings us to our next section, the ultra-finitist revolts. These are the folks, philosophers, mathematicians, who looked at this whole situation and basically said, nope, we've had enough. So what exactly is ultrafinitism? Well, it's a pretty wild idea. It basically says that the only numbers that are real, the only ones that are meaningful, are the ones that can physically exist. Like, if you can't build it, or count it, or represent it using the stuff in our actual universe, then it's not a real number. It's just a neat idea in your head, an abstraction. And this quote really sums up their whole philosophy. They're not just saying infinity is wrong, they're saying it's a distraction. It's this messy concept that creates all these weird paradoxes and stops us from ever having a system of math where everything is provable, where every question actually has a concrete answer. Okay, but why is throwing out infinity such a big deal? Well, because it's a direct attack on one of the biggest names in the game, Gödel, and his famous incompleteness theorems. So Section 3 is all about how these rebels plan to take on the giant. So here's their master plan. It's a 3-step move. First, you set a limit, a really, really big but still finite number. Let's call it n. Maybe it's the number of particles in the universe. Step 2. You declare that anything beyond n isn't just wrong, it's gibberish, it's meaningless. It's like trying to divide by a color. The system just doesn't recognize it. And then, the payoff, step 3. By doing this, by creating this finite sandbox to play in, you suddenly get a complete system. Every single statement inside the sandbox can be proven either true or false, no exceptions. And that right there is the big trade-off. Think about it. Classical math gets to play with infinity, which is super powerful and elegant, but the price you pay is incompleteness. You get statements that you know are true, but can never, ever prove. The ultra-finitists, they give up infinity. They work in a smaller, physical, more practical world. And what do they get in return? Completeness. A system with no unprovable truths. Everything is knowable. Now, to be super clear, they're not disproving Gödel. You can't. His logic is solid. What they're doing is more like changing the game. It's like Gödel set up this infinite chessboard and proved that some positions are unwinnable. The ultra-finitists just come along and say, cool, we're going to play checkers on a smaller board instead. And on our board, every game has a winner. They just refuse to play by his rules. All right, so for a long, long time, this was all just, fun stuff for philosophers to argue about over coffee. Purely theoretical. But then something changed. Something was built. And that brings us to the craziest part of this story. Section 4, the AI is a finitist. This is where this obscure philosophy suddenly becomes very, very real. And here's the best way to think about it, a great analogy from the source material. An AI is like a camera, but it's a camera with a fixed resolution. It might have billions of pixels, creating incredibly detailed pictures, but it will always have a fixed number of pixels. It can't zoom in forever. Its ability to see the world is physically limited by its own hardware. It lives in a finite world. So let's connect the dots here. Why is an AI an ultra-finitist? Well, its brain is its parameters, right? All those weights and numbers. It's a massive number, for sure, but it's a finite number. That's its n, just like the one we talked about before. It can only understand the world based on the finite data it was trained on. So if you give it a concept that requires something beyond those physical limits, it's just gibberish to the machine. It literally can't compute it. And what does that mean? It means that inside its own world, inside its own set of rules, the AI is a complete logical system. Okay, and if you've been following along, this is where your brain might start to melt a little bit. Because if this is true, the implications are just huge. Welcome to our final section, Truth in the Machine. If we've actually built a complete system, what does that do to our ideas of truth, or even lies? No, seriously, think about this. If you have a system where everything inside its world is provably true or false, can that system even lie? I mean, a lie means you know the truth, but you choose to say the opposite. But what if the machine is hardwired to only process what is provably true according to its data? What does a lie even look like then? So the AI's reality really splits into two categories. In one bucket, you have provable truth. This is everything that fits inside its finite world, inside its N. Any question in this bucket has an answer. It can be resolved. But in the other bucket, you have what we'd call meaningless syntax. This is where infinity lives. This is where those Gödel paradoxes go. For the AI, this stuff isn't false. It's worse. It's just noise. Incomprehensible static. It doesn't compute. And that leaves us with one last, kind of scary thought to chew on. We've built a machine whose world is finite, and because of that, it's complete. It can't even get tangled up in the abstract ideas like infinity that cause us humans so many problems. So here's the question. Does that make the AI's truth the only truth that matters? If a system is physically complete and grounded in reality, is its truth more real than ours? I'll let you think about that one.